Oh, hi there. It's Tutor Grant from the Math Mastery Academy. And if you're tuning in, you were probably in the class last week where, to be quite fair, I was not at my full capabilities. I was feeling a little sick, and it was starting to influence my thinking and just ability to do math. But I tried to make the point, I hope you believed me, that when you find a problem that defeats you, that's not a bad thing. That's actually a really great thing because it means you have something to chew on, something to work on, and that's like a heavy barbell that's going to get your brain stronger. I also told people if you go to sleep after working on a problem that's defeated you, if you think about the problem in the morning, you may have an insight. That's exactly what happened to me here. I couldn't believe it. I couldn't believe what we had missed. Look at all the things that we got. Like we made so many notes about this situation that it's like covered in notes. We still didn't see this like thing that was totally obvious to me when I woke up the next morning. So just to recap the problem here, we have this is the same as this, and this n is the midpoint, and this was 2 from there to there, and this is 1. So it's a rectangle that's twice as long as it is wide. So that means that if we did divide it at the midpoint, that those are squares, right? Those are 2 squares. And then we have an equilateral triangle that's going across the whole middle of the diagram, like from DM, and so that's the same as that because equilateral is the same as that. And what were we looking for? Well, we were looking for this angle here, XCD. Okay, we want that angle, which is about as hard an angle to find in this diagram as possible, okay, to be fair. All right, well, if we know, here, it's so easy. It's so easy when you just notice this, okay? And what do you have to notice? You just have to construct this diagonal too. Okay, that's all we need. And then we note that that diagonal is going to be the same length. Ah, look, an isosceles triangle. It's just that easy. Okay, and then what do we know about this isosceles triangle? Well, we know this is 45 degrees here. This one is 60 degrees. This one is 45 degrees. Those are all special triangles, equilaterals, and right angle isosceles. And so that leaves a little gap here of 90 plus 60 plus something, 30 degrees. Okay, so once we know that that's 30 degrees, it means we have 150 to split between MXC and MCX. So each one is 75 degrees. Okay, but that's 75 degrees here. And we already know that that is 45 degrees. And we are asked for this angle here, which would be 75 minus 45 gives us 30 degrees. Okay, so the required angle that we were asked to find was 30 degrees. It was that simple. And the only thing, you'll notice, the only thing we didn't note on this diagram that this up here was also root 2, which would give us this idea. We're just missing that. We kept on like chasing our tails, finding different ways to express this angle, and so long as we weren't using that idea that it was isosceles, we couldn't solve it. It was impossible. We just chased our tails around and around and around. So that little bit of frustration, I hope you found it fun and got some enjoyment out of watching me squirm. And then we had this question, which I have ready for us over here, blank copy. I'm going to do my best to explain this without a whole lot of extra explanation, but this one I actually had to think about for a few days. And as I was thinking about it, I was imagining different things with the figure, and I feel like I made some good progress on my geometric imagination. So I was pleased to have gone through that, and then I'm pleased to report that I found a solution. So here the thing is, like if we have this is A, that length, and that is B, then this is A plus B. So that means there's somewhere along here, like if I were to draw an arc there, like that to that point, that if I drew this arc from here, it would meet at that point, right? Those two arcs would meet. So let's label that point. Let's call it X. Call it whatever you want. I'm calling it X, okay? And now we don't need these arcs, but we know that that side BC is B and A added together. All right. Now let's go ahead and construct some triangles here. And they're going to be isosceles. Okay. This one here, this triangle here. It's also isosceles. Okay, so we got 2 isosceles triangles. If we bisect these angles like that, these will be meeting at 90 degrees. Because why? Well, the two triangles are similar, right? So which triangles am I speaking of? I'm speaking about this triangle here is similar to this triangle here. So if they're similar, those two angles have to be the same, but because they add to 180, then they're 90. Okay, so that means that these angle bisectors are also bisecting the sides of that triangle. Now, here's a general thing that you may or may not know about triangles, but it's a useful thing to know. Triangles have something that's called a circumcenter. I'm going to draw a triangle here, do my best to have a cool triangle. The circumcenter refers to, if we were to, every triangle has one and only one circle that hits all the points. Okay, so there's one circle that does this, that goes around and hits these points. These three lines can be chords. It doesn't matter. One of them doesn't have to be the diameter or something like that. They can all be chords to the circle. But the way you find the center of this circle is you find the perpendicular bisector of each side. So this line here perpendicularly bisects that side, let's say. This line over here perpendicularly bisects that side. And this line over here, say that's the midpoint, and that's your right angle, perpendicularly bisects that side. Okay? They will all meet at the center of the circle. And that's not that hard to show, because I mean, if we go out here and build this triangle, we'll notice, like, if this is this line here, the edge, it's going to be tangent. Sorry, it's going to be parallel to a tangent on the outside of the circle, right? At the outside of the circle there. So if you have a tangent there, like where the road hits the tire, like it's a line that's tangent to the circle, that's going to be perpendicular to the radius. Okay, so the radius is always going to be there. In other words, if you have a road and a tire, the center of the tire is always directly above the road, and it makes a 90-degree angle. With a circular wheel, with like some kind of oblong wheel, that may not necessarily be true. Circle wheel is true. Okay, so that's one thing. So that since that's going to be parallel to this chord here, like I can make this triangle, and those two are going to be the same. Those are going to be similar triangles on either side. It's all just a circle property. So that gives us that those meet at this point. Well, this angle bisector, we were asked to show that this angle bisector goes to this point, and this angle bisector here goes to that point, and this perpendicular bisector will go to that point. Well, the thing about that is this bisector here is the perpendicular bisector of AX. This angle bisector here is the perpendicular bisector of DX. So when we look at this triangle here, we can note that this point is actually the circumcenter of that triangle, and therefore they all meet at a point. That's how I would do that. Now, this is something that certainly bears more investigation. So let's go ahead and find some resources. So if you want more viewing about circumcenters, there's a Khan Academy video that covers circumcenter. That's not a bad place to go. There's also different like shorts where we're talking about the different centers that triangles have. So there's the orthocenter, which comes from the angle bisectors. There's the circumcenter, which comes from the perpendicular bisectors, etc. And you can see the different, and then there's the median. Yeah, anyway, there's the third one. Anyhow, there, in-center, circumcenter, orthocenter, and centroid, right? So yeah, you might want to look at that one from the organic chemistry tutor as well to find out more about this topic. But having those at your fingertips for geometry questions certainly is helpful, and I wasn't able to see that in the moment because, man, I was not all there. Okay, so I hope that's helpful and look forward to seeing you in class very shortly. Bye for now, everyone.